Hello, Hashima. This is lesson 103 for Friday, April 3rd. This lesson is about solving volume word problems, which is something that we've done for a while, but they can be kind of tricky, especially when they're multi-step. So just want to review some basic things about volume. So we'll get started. All right, so let's start with fact number one. So volume, just to review, is the number of cubic units that it takes to fill up a solid figure. So be careful with this because volume is what you put inside. It's not just what you cover on the outside or the top or the bottom. It's what fills a solid figure. And remember, it's only for three-dimensional shapes. So fact number two, to find the volume, we multiply the length, width, and height of a three-dimensional prism to find the volume. So the most basic formula you can use for this is V equals L times W times H, which is right down here in fact number three. But also, if you remember, if you've already multiplied the length and the width, we call that the base, or B. So you can say that volume equals base times height as well. So a two-dimensional shape is just length times width, and that's on the bottom of the shape. So that third dimension height is what makes it volume. So those two formulas are right there on fact number three. They'll be very useful in solving all the problems. So if you look at the concept review, this is just three basic volume problems. The first one shows individual cubes. So I had to manually count them up. So I counted up the length is 5, the width is 3, and the height is 3. Then I took the time to write out the formula so that I didn't mix up any of the numbers mentally. So 5 times 3 times 3 gets us 45. So the volume of this prism is 45. That means if I counted all the pieces that fill up this box, it would be 45 of them equally. The next one does not have the individual cubes, but it already gives you the dimensions. So you're going to do 8 times 4 times 5 using the volume formula, which will give you 160. So this box has a lot bigger volume than the first one, which is only 45. The last one is a slightly different type of picture. This type of picture shows something that's only partially full. So the idea here is that there's the outline of the box on the edges here, and then it's only filled in the bottom layer and then one for each height. So I counted again, just like I did in the first one. The length is 5, the width is 3, and the height is 3. So actually, if you look at the dimensions, it's the same as the first box, but this box is only partially full. So 5 times 3 times 3 is 45. So those are three different ways you might see a volume picture presented. So let's go over the problem solving section. So this is a word problem that is actually 2 steps. So you have to make sure that you not only use the picture, but that you read it carefully. Jack used cubes to make a right rectangular prism. He then made a smaller prism that only used 1/4 of the number of cubes. What was the volume in cubic centimeters of the smaller right rectangular prism? So when I saw this problem, I knew that this involved 2 prisms, the bigger one that's in the picture, and then a smaller one that we don't know about yet. So I divided up my workspace into 2 sections, one for the bigger prism, one for the smaller one. And for the bigger prism, I had everything I needed using the picture. So what I did was manually counted the dimensions. So the length was 8, the width was 2, the height was 4. So I wrote out the volume here is 64 using the formula 8 times 2 times 4. However, in the problem, it says that the smaller prism has only 1/4 the number of cubes. So what I had to do then is scale down the number of cubes from the first prism, which was 64, scale it down to only 1/4 of its size. So I wrote out 1/4 of 64. Now, if you remember, when you see that word of, when you're scaling something down, it's multiplication. So really, a way to think of it is look at this bar diagram down here that I drew. If you have 64 total cubes and you're splitting it into 4 pieces, you're only finding one of those 4 pieces, 1/4 of 64. So this is kind of like a division problem, if you think about it, because multiplication and division are related. So 1/4 times 64 over 1 is going to give you 64 over 4, which gives you 16, which matches with the picture that I drew down here. So the final answer to the problem is 16. That's the volume of the smaller prism that only had 1/4 the amount of cubes that the bigger one did. All right, the next problem is a thinking problem. Notice there's no numbers really here other than what the total volume is, but it's asking you to actually think about what volume means. So Barbara fills a box with layers of unit cubes. The box had a volume of 125. Which sentence about the box must be true? So I chose B. The box was filled with exactly 125 cubes. But let's talk for a second about why those other answer choices are not right. So A, there were 125 unit cubes in the bottom layer. Now, it does not tell us how many layers are in her box, but we can't prove that there's 125 in the bottom. We don't know that it's only a single layer box, so we don't know if that's true. C, there were 125 cubes in each layer. Again, if the total volume is 125, there can't be 125 cubes in each layer. That would be too big. And D, the box was filled with less than 125 cubes. That's not right because it already tells us that the volume is 125. So the correct answer there was B. So you're going to try some more of these problems. Some of them do get a bit tricky. I really encourage you to label everything and show your work so that rather than doing it mentally, you have a trail of your numbers so that if you do make a mistake, you can go back and fix it. We will talk to you on Zoom. Have a great day.